Assalamualaikum. My name is Musir Razim bin Mawazi and I am the project manager of Starling Solutions. And this project is Teras Jenang Wastewater Treatment Plant, and this is my team members.
I'm Nur Anisha Fadin binti Muhammad Nasir and I'm the project engineer for electrical.
Okay, I am Ahmad Syamsul Rais bin Ahmad Zamili as a mechanical and electrical coordinator.
Hi, my name is Sufisa Atika binti Azwar and I'm a project planner.
My name is Nur Alia Natasha binti Zaidi and I am the project engineer for mechanical.
I am Nailina Suha binti Ahmad Azizi and I am the safety manager.
As you can see, from the ladder diagram, we could say that there are three processes in which there are master and slave. At the master, there are process 7 and 8. In process 7, there are 4 sections. There are system on, tertiary feed pump, wash water pump, and the analog sensor, which is US07. In the tertiary feed pump, there are pump number 1 and pump number 2, which will be explained in the demonstration. And wash water pump, there are pump number 3 and pump number 4. While in the analog section, there are analog input address, which is 3302. In process 8, there are 5 sections: the system on, filtering process, backwash and recycle, RTC backwash, and RTC for the sampler. Now the system on is similar to the system on of process 7. While in the filtering process, the outputs are only PV01. And the backwash and recycle process and RTC backwash. For this RTC, I use this function to indicate that it will open at 12 AM, 6 AM, 12 PM, and 6 PM. So basically every 6 hours for 5 minutes of duration. And it will open the backwash cycle. It will turn on the backwash cycle to send the data link to process number 9, which is the slave. And this is the RTC for the sampler, which will open at 4 AM and 4 PM twice a day. Under the slave area, there are process 9. In process 9, there are 4 sections: the final effluent, backwash clock, ultrasonic sensor US09, and the sampler. For the final effluent, there are pump 2 and pump 3. For the backwash clock, the output is only pump 1. And for the ultrasonic sensor, there are analog input address, which is 232. And lastly, the sampler. There are data link between process 8 and process 9 for process backwash clock and for the sampler process.
For this program, we're using Omron Programmable Controller Training Kit, and this is the master. We're using the Sysmax CS1 GCPU42H for process 7 and 8, and this is for the slave CQM1H CPU51 for process 9, and lastly, the ultrasonic sensor signal generator that we use at process 7.
Okay, this step is the scanning step. Okay, first we need right click at the symbol and then we go to properties. Next we go to the IO information. Okay, As we can see here, this is the address. Okay, since we have the problem for the recording video in the lab, I mean screen recording, so here are some snapshot that we take. Okay, next is for the data link. Okay, as we know, data link is used for PLC to connect the master and slave. Okay, first step is need the data link. We go to online. Okay, when we online, then we need to choose the data operation mode status, and then we set the data link stop. Okay, after a few seconds, a pop-up with the write complete. Next is run. Okay, the step for run is same. We go to online and then the operation mode status, and then we run. Okay, for the run, the status we write fail, but don't worry, actually it's success to connect the master and slave.
When we push the start button 0.01, the system will turn on. As you can see, the output of 1.08 is automatically turned on. This is because when we push the start button, it will also turn the system on for process 8. And when the system is on in process 8, the BV01 will open. Back at tertiary feed pump in process 7, we use ultrasonic sensor as the analog input. In our program, when the ultrasonic sensor reaches the voltage above 9 volt, it will detect as high. When the voltage is below 9 volt, it will detect as low. When the system on for process 7 and 8, the pump in tertiary feed pump will auto start and stop based on 07 US01. As you can see, in the event of a high level as monitored by 07 US01, duty pump will start. In the event of a low level as monitored by 07 US01, duty pump will stop. The duty pump alternates after every cycle. In case of any duty pump fails to start, an alarm will turn on and the standby pump will become the duty pump. For demonstration purpose, I will force off at pump 07 to output 1.01. And when it turns to be the duty pump, the standby pump 071 will be the duty pump and alarm 71 will turn on. Same thing happen when pump 071 is failed. The standby pump will become the duty pump and alarm 72 will turn on. Now at wash water pumps, the duty pump can only start when they receive signal from inlet screening, which is 01 SC01. The same principle applies at this section. The duty pump is automatically start and stop based on 07 US01. In the event of a low level detected in the sump, as monitored by level sensor 07 US01, duty pump will stop. While the level sensor 007 US01 detects the level as high, the duty pump will start. The duty pump alternates after every cycle. In case of any duty pump fails to start, an alarm will turn on and the standby pump will become the duty pump. For demonstration purpose, I will first off at pump 073, output 1.02. And when it turns to be the duty pump, the standby pump 074 will be the duty pump and alarm 74 will turn on. Same things happen when pump 074 is failed. The standby pump will become the duty pump and alarm 73 will turn on. And now for the next process.
For process 8, the system is on due to the push button at process 7. As you can see, when the system is on, the ball valve BV01 is automatically open. BV01 will stay open until the timer that we set on RTC turns on. And for this demonstration, we will set the PLC clock at 12 AM. The RTC are set to be on for 5 minutes. Once the time are set at 12 AM, ball valve BV01 is automatically closed for backwash and rinse cycle process. At the same time, BV02 will be open. Once BV02 is open, it will set a timer for 280 seconds for the backwash process. While BV02 is open, pump 71 and pump 72 in process 7 will not start until BV02 is closed. Once the timer is done, it will open BV03 for rinse process and it will close BV02.
BV3 will be open for 30 seconds. After 30 seconds, the BV3 will close and BV1 will automatically open. Coming to process 9.
For the system in process 9 to turn on, push button 0.01 in the slave PLC must be turned on. Pump 09P01 will turn on if the timer that we set on RTC turns on. As we demonstrated before, when we set the PLC clock at 12 AM, pump 09P01 will automatically turn on simultaneously with BV02. Pump 09P01 can only run when US01 is at high condition and will stop when it's in low condition. Pump 09P01 will turn on the timer for 180 seconds, then it will stop. While pump 09P01 is turned on, the main rising pump will not function due to interlock. The main rising pump can only start when pump 09P01 is not running. When the analog address for ultrasonic sensor is more than 9 meter, the sensor will detect it as high. If it's lower than 9 meter, it will detect it as low. In the event of a high level detected in the sump, as monitored by level sensor 09 US01, the duty pump starts. In the event of a low level detected in the sump, as monitored by level sensor 09 US01, the duty pump stops. The duty pump alternates after every cycle. If the duty pump fails to start, the standby pump becomes the duty pump. A priority alarm is raised. From time to time, twice per day, at 4 am and 4 pm, there will be sample taken by sampler 09SA01. For demonstration purpose, when the PLC clock is at 4 am, the sampler will run for 5 minutes. That's all for our demonstration on Teras Jernang Wastewater Treatment Plant. On behalf of Starling Solutions, we thank you for your time. Assalamualaikum.